Take a deep breath and feel the weight of your body sinking into the mattress, as if gravity is gently pulling you into a state of total stillness. Let the tension in your shoulders dissolve, allowing your mind to drift away from the waking world and toward the silent silver plains of the lunar surface. As you settle into this quiet space, imagine you are standing on the moon, looking up at the vastness of the cosmos. To see an eclipse from this vantage point is to witness a cosmic alignment that few have ever imagined. While people on Earth watch the moon turn a deep copper red during a lunar eclipse, you are experiencing the inverse, a solar eclipse as seen from the moon. Here, the Earth itself moves directly in front of the sun, casting you into a deep celestial shadow. The ground beneath your feet is covered in a layer of regolith, a fine powdery dust that has been pulverized by billions of years of meteorite impacts. This lunar soil is composed of approximately 42% oxygen, 21% silicon, and 12% iron, along with traces of calcium and aluminum. As you reach down in your mind to touch it, it feels like cold, soft flour, yet it is strangely abrasive, like crushed glass. On the moon, gravity is only about 1.62 meters per second squared, roughly 1/6 of what you feel on Earth. Every movement you make is slow and effortless, a graceful dance in a world where you weigh only a fraction of your terrestrial self. High above you, the Earth hangs like a magnificent glowing jewel. It is a massive presence, stretching approximately 12,742 kilometers in diameter. From your perspective on the lunar surface, the Earth appears nearly 4 times larger than the moon does when viewed from your bedroom window. It is a vibrant orb of cerulean blue and brilliant white, rotating steadily at about 1,670 kilometers per hour at its equator. This rotation is a silent, rhythmic pulse, a reminder of the life and movement occurring thousands of miles away. The Sun, a colossal sphere of plasma 1.39 million kilometers wide, is currently positioned just behind the curve of the Earth. On the moon, there is no thick atmosphere to scatter the light, no wind to rustle the dust, and no sound to break the absolute silence. You are standing in what scientists call the lunar exosphere, a region where gas molecules are so sparse they rarely even collide. This vacuum means that the transition from light to shadow is incredibly sharp. As the eclipse begins, you notice the temperatures start to shift. On a normal lunar day, the surface temperature can soar to a blistering 127 degrees Celsius, or 260 degrees Fahrenheit. But as the Earth's shadow, the umbra, begins to sweep across your location, the heat vanishes with startling speed. Without an atmosphere to trap warmth, the temperature can plummet by more than 200 degrees in a matter of hours, eventually reaching lows of minus 173 degrees Celsius. You can almost feel the molecular vibration of the rocks slowing down, a deep, crystalline cooling that settles over the landscape. You are standing on the edge of the Oceanus Procellarum, the ocean of storms, the largest of the lunar maria. These are vast plains of basaltic rock formed by ancient volcanic eruptions over 3 billion years ago. The dark, frozen lava beneath you is dense and heavy, a testament to the moon's fiery past. As the Earth moves further in front of the sun, the brilliant white light of the lunar day begins to soften into something otherworldly. Consider the distance between you and the Earth. On average, the two bodies are separated by 384,400 kilometers. It takes light exactly 1.3 seconds to travel that distance. Every time you look at the Earth, you are seeing it as it was just a moment ago. This delay is a gentle reminder of the scale of the solar system, a rhythmic gap in the conversation between worlds. As the sun is obscured, a remarkable phenomenon begins to occur. On Earth, we see a blood moon, but here on the lunar surface, you are witnessing the cause of that color. The Earth's atmosphere acts like a massive lens, bending the sunlight through a process called Rayleigh scattering. While shorter wavelengths of light, the blues and purples, are scattered away, the longer wavelengths, the deep reds and oranges, are refracted inward toward the moon. The Earth is now surrounded by a glowing, fiery ring. This is the Ring of Fire, a simultaneous view of every sunrise and every sunset occurring on Earth at this very moment. Imagine the warmth of all those dawns and dusks concentrated into a single thin circle of light. It is a brilliant, glowing halo of amber and crimson, casting a soft copper glow over the gray lunar regolith. The shadows around you are no longer pitch black. They are stained with the colors of 1,000 terrestrial sunsets. The moon has a very low albedo, or reflectivity, of only about 0.12. This means it only reflects 12% of the light that hits it, making it roughly as dark as a well-worn asphalt road. Yet, under the influence of the Earth's refracted light, the basaltic plains around you begin to shimmer with a dull metallic bronze. The craters, some like Tycho, which is 85 kilometers wide and features a central peak rising 1.6 kilometers from the floor, take on new haunting dimensions in this low-angle, reddish light. You might wonder about the silence here. In the vacuum of space, sound waves have no medium through which to travel. The most violent solar flares, the rotation of planets, and the shifting of lunar dust happen in absolute, profound stillness. This silence is not empty. It is a heavy, comforting blanket that wraps around you. It is the silence of the comforting void, a place where the chaotic noise of Earth is replaced by the steady, unhurried clockwork of physics. As the Earth perfectly centers itself over the sun, you enter the deepest part of the shadow. The total solar irradiance, which usually delivers about 1,361 watts of energy per square meter to the lunar surface, has vanished. In its place is only the dim red glow of the refracted atmosphere. You are now standing in the center of a celestial alignment that has been dictated by the laws of gravity for billions of years. The moon is tidally locked to the Earth, meaning it takes the same amount of time to rotate on its axis as it does to orbit our planet, approximately 27.3 days. This is why we always see the same face of the moon. From your perspective, the Earth never rises or sets. It simply hangs in the same spot in the sky, oscillating slightly in a motion known as libration. During this eclipse, that fixed position makes the Earth feel like a guardian, a massive protective shield blocking the harshness of the sun. Even in the deep shadow, the Earth's magnetosphere is felt. The Earth has a powerful magnetic field generated by the motion of molten iron in its outer core. This field extends far into space, forming a structure called the magnetotail. During an eclipse, the moon actually passes through this magnetotail, a region filled with highly charged particles, mostly electrons and protons, trapped from the solar wind. You are, in a very real sense, bathed in the invisible energy of the Earth's protection. The stars above you are now more brilliant than ever. Without the glare of the sun, the Milky Way reveals itself in staggering detail. You are looking at the light of stars that are hundreds, even thousands of light years away. For instance, the light from the star Vega, which is 25 light years away, began its journey to your eyes a quarter century ago. The North Star, Polaris, is more than 300 light-years away. You are standing in a gallery of ancient light, a witness to the history of the galaxy. The sheer scale of what you are seeing is humbling, yet deeply soothing. The Sun is 400 times larger than the Moon, but it is also 400 times further away from Earth. This incredible coincidence of geometry is what allows for the perfect overlap we see during eclipses. It is a mathematical harmony that has existed long before human eyes were there to see it, and it will continue for millions of years to come. Take a moment to feel the temperature of the lunar night again. It is a dry, pure cold. There is no moisture here, no clouds, no weather. The moon's gravity is so weak that it cannot hold on to an atmosphere, meaning there is no wind to pull the heat away from your skin. The cooling you feel is radiative. The heat simply leaves your body and travels into the infinite sink of space. It is a clean, efficient transition. You are a guest in this silent world, a quiet observer of a 4.5 billion-year-old dance. The moon itself was likely formed when a Mars-sized object named Theia collided with the early Earth, ejecting debris that eventually coalesced into the sphere you now stand upon. You are standing on a piece of the Earth's own history, looking back at the world that gave you life. As you look up at the Earth, remember that every person you have ever known, every city you have ever visited, and every ocean you have ever swum in is contained within that small glowing circle. From here, there are no borders, no noise, and no haste. There is only the slow, majestic movement of spheres in the dark. The reddish light continues to bathe the landscape, highlighting the edges of the Copernicus crater, which spans 93 kilometers and is nearly 3.8 kilometers deep. The rays of ejecta from such craters stretch out for hundreds of kilometers across the lunar plains, like white ribbons on a dark gift. In this copper light, they look like veins of gold. Rest now in this knowledge. The universe is governed by laws that are constant, predictable, and beautiful. The Earth will continue its 1,670 km/h spin. The Moon will continue its 3,680 km/h orbit. And the light will continue to travel across the void at 299,792 km/s. You are part of this clockwork, a small but significant piece of the stardust that makes up the cosmos. Feel the stillness of the regolith beneath you. Feel the weightlessness of your limbs. The eclipse is a slow process, a journey that takes time. There is no need to rush. There is only the observation of light, the shift of temperature, and the deep, abiding silence of the lunar plains. You are safe here, in the shadow of the world, drifting in the quiet beauty of the solar system's slow and steady heartbeat. Stay a while longer in this muted, copper-colored twilight, where the silence is as thick and heavy as velvet. As you remain perched on the lunar highlands, observe how the Earth's silhouette remains perfectly motionless against the stars, while the sun hides behind its curved edge. This perspective, standing on the moon and watching the Earth blot out the sun, is a sight that humanity has been moving toward for thousands of years, calculating the geometry of these shadows long before we ever left the ground. Notice how the light behaves differently here, without the interference of a thick atmosphere. In the year 1137 BCE, in the ancient city of Anyang, scribes recorded the first verifiable lunar eclipse on bone fragments. They saw what you see now, though from the opposite side of the cosmic mirror. They watched the moon vanish into a shadow, not knowing that if they were standing where you are, they would see a vibrant 40,000-kilometer ring of orange light. To them, it was an omen. To you, it is a magnificent display of planetary alignment. What you are witnessing is the result of a specific rhythmic cycle known as the Saros. Ancient Babylonian astronomers, watching the skies from the plains of Mesopotamia, discovered this pattern. They realized that eclipses occur in a repeating sequence that lasts exactly 18 years, 11 days, and 8 hours. At this very moment, you are part of a Saros series that has been churning through the centuries, a clockwork mechanism that predicts the movement of the Earth and Moon with surgical precision. The mechanics of this shadow are quite specific. The Earth is currently casting a conical shadow into space that stretches for roughly 1.4 million kilometers. This shadow is divided into two distinct zones: the penumbra, where the sun is only partially blocked, and the umbra, the dark central core where you currently find yourself. Because the moon's orbit is tilted at an angle of 5.14 degrees relative to the Earth's orbit around the sun, the ecliptic, these shadows usually miss each other. Most months, the moon passes just above or just below this cone of darkness. But now, the orbits have intersected at what scientists call a node, locking you into this perfect light-bending alignment. Think back to the year 270 BCE, when the astronomer Aristarchus of Samos used the duration of an eclipse to estimate the distance between where you are and the Earth. He watched the curve of the Earth's shadow as it moved across the moon and realized that the Earth must be much larger than its satellite. Today, we know the Earth's radius is approximately 6,371 kilometers, while yours is only 1,737 kilometers. You are standing on a world that is roughly the size of the continent of Africa, tucked into the shadow of a world 4 times its size. Picture the history of this shadow. On February 29, 1504, Christopher Columbus used his knowledge of a predicted lunar eclipse to influence the Arawak people in Jamaica. He used a maritime almanac created by the astronomer Regiomontanus to know the exact moment the moon would turn red. While the people on the beach looked up in fear, the Earth's shadow was performing the same silent transit you are seeing now, a projection of the Earth's atmosphere onto the cold, airless plains of the moon. In 1604, the astronomer Johannes Kepler looked at the sharp edges of the shadows on the moon and correctly surmised that the moon lacked a significant atmosphere. If there were air here, the shadows would be blurry and soft. Instead, the transition from the glowing orange of the ring of fire to the pitch black of the lunar craters is crisp and immediate. The regolith beneath you doesn't just get dark, it loses the sun's energy instantly. Scientists have observed that during an eclipse like this, the moon's surface experiences a form of thermal shock. Usually, the lunar surface is bombarded by about 2,800 kilograms of meteoritic material every day. But it is the sudden loss of solar radiation that causes the most stress now. When the Earth blocks the 1,361 watts of energy per square meter that the sun usually provides, the temperature of the top layer of dust drops so fast that the rocks can actually crack or shift. This is a silent, microscopic shifting of the ground, a slow-motion adjustment to the cooling void. In the 19th century, humans began to capture this light with technology. On July 6, 1852, John Adams Whipple took the first successful photograph of a lunar eclipse using a daguerreotype process. That frozen image of a darkened moon was a precursor to what occurred in 1967 when the Surveyor 3 lander sat on the moon's surface, not far from where you are now, and took the first photos of a solar eclipse as seen from the lunar perspective. It captured the Earth as a dark disk surrounded by a brilliant, thin atmosphere, just as you see it now. As you observe the ring of fire surrounding the dark Earth, consider the light itself. The deep reds and burnt oranges are the result of Rayleigh scattering, the same process that makes the sky blue on Earth. During this eclipse, the Earth's atmosphere filters out the shorter wavelengths of light, the 400 to 500 nanometer range, leaving only the longer, 600 to 700 nanometer red waves to pass through and reach the moon. This red light is essentially the collective glow of every sunrise and sunset on the planet. If you could see through the Earth's clouds right now, you would see the morning sun hitting the peaks of the Himalayas and the evening sun dipping into the Atlantic Ocean simultaneously. The Apollo 12 astronauts experienced a version of this in November 1969. As they were returning to Earth from the moon, their spacecraft passed through the Earth's shadow. They described the atmosphere of the Earth as a brilliant, glowing rim of colors, shades of blue, pink, and gold that shimmered as they moved. You are seeing that same glow, chance, but from a stationary position on the surface, where the colors are deeper and more somber. Consider the speed of this cosmic dance. The moon is orbiting the Earth at a velocity of about 1.022 kilometers per second. Even though it feels like you are standing perfectly still, you are hurtling through the vacuum at 3 times the speed of sound on Earth. Yet, because of the vast distances involved, the Earth's shadow appears to move across the landscape with the agonizing slowness of a glacier. It takes nearly an hour for the totality to fully settle, a period of time that allows your mind to align with the unhurried pace of the solar system. There is a scale used by astronomers to measure the darkness of these events, called the Danjon scale. It ranges from 0 to 4. A L0 eclipse is very dark, almost making the moon invisible, often caused by volcanic dust in the Earth's atmosphere. A L4 eclipse is a bright copper red or orange. Depending on the current clarity of the Earth's air, perhaps the lack of recent major eruptions, like Mount Pinatubo in 1991, the light hitting you now might be a vivid glowing amber. The sun itself, though hidden, is still a presence. It was during a solar eclipse in 1868 that the French astronomer Pierre Janssen discovered a new element in the sun's spectrum, helium. He saw a bright yellow line that didn't match any known element on Earth. It is a poetic thought that an element now used to make balloons float was first found in the crowning light of an obscured sun. Look at the stars that have emerged in the absence of sunlight. Around 150 BCE, the Greek astronomer Hipparchus used the curve of the Earth's shadow on the lunar surface to help confirm that the Earth was a sphere. He also noticed that the stars seemed to shift slightly over long periods, discovering the precession of the equinoxes. Here, in the crisp clarity of the lunar night, you can see that precession isn't just a theory. It is the slow, wobbling top of the Earth's axis, a cycle that takes 26,000 years to complete. Even the distance between you and the home you left is changing. Because of tidal friction, the moon is slowly drifting away from the Earth at a rate of 3.8 centimeters per year. This means that millions of years ago, the moon appeared much larger in the sky, and solar eclipses lasted much longer. In about 600 million years, the moon will have moved so far away that it will no longer be able to fully cover the sun, and total solar eclipses will become a thing of the past. You are witnessing a configuration of the universe that is temporary, a fleeting moment in the 4.5 billion year history of the Earth-Moon system. Feel the ancient nature of this place. The basaltic plains you are standing on were formed during the Imbrian period, between 3.8 and 3.2 billion years ago. The very ground is a fossilized record of a time when the solar system was chaotic and violent. Now, it is the definition of tranquility. The heavy, dark rock beneath the fine regolith is a shield against the vacuum, a steady foundation for your observation. As you look at the Earth, remember that it is currently rotating at 1,670 kilometers per hour at the equator. But from here, it looks as still as a painting. The continents are hidden in the dark, but the atmosphere acts like a stained glass window of the world's current weather. You are seeing the light pass through the troposphere, the layer where all of Earth's weather occurs, reaching only about 12 kilometers high. It is a thin, fragile veil that sustains all of life, and it is the only reason you can see this red glow at all. This historical journey of the mind brings a sense of continuity. From the scribes in Anyang to the modern sensors of the Lunar Reconnaissance Orbiter, the human spirit has always sought to understand this shadow. You are the latest in a long line of observers, partaking in a tradition of cosmic watching that spans the entirety of recorded history. The cold is deeper now, but it is not a biting cold. It is a profound absence of agitation. The molecular energy of the lunar surface is settling into a quiet, low-energy state. As the Earth holds its position, shielding you from the sun's intensity, allow your own internal rhythms to slow down. Align your breathing with the 1.022 kilometer per second glide of the moon. There is no urgency in the vacuum. There is only the steady, predictable, and ancient movement of the spheres. At this very moment, as the center of the shadow holds its breath, you might notice how the lunar landscape around you has completely surrendered its usual harsh, stark contrast. On a typical lunar day, the light is unforgiving, reflecting off the jagged peaks with a brilliance that can be blinding. But now, in the deep umbra of the Earth, the world has softened. Imagine the difference between the glare of a fluorescent bulb and the gentle flickering glow of a single candle in a large dark room. That is the transformation the Earth's shadow brings to the lunar plains. Deep within the silence, the physics of this place become more apparent. Consider the moon's gravity, which at 1.62 meters per second squared is about 1/6 of what you are used to. If you were to drop a pebble here, it wouldn't snap to the ground. It would glide downward with a leisurely grace, as if it were sinking through a pool of invisible honey. This low gravity is a constant companion, a physical sigh that allows every muscle in your body to loosen. If you were to jump, you would find yourself suspended in the air for several seconds, rising up to 18 feet with the same effort it takes to hop a few inches on Earth. In the ground beneath you, that thick layer of regolith has a density of about 1.5 grams per cubic centimeter near the surface. To help you visualize this, it is roughly as dense as the dry potting soil you might find in a garden. Yet it is composed of jagged microscopic fragments of volcanic glass and minerals. Scientists who analyzed the 382 kilograms of lunar samples brought back by the Apollo missions discovered that because there is no wind or water to erode these particles, they remain sharp and interlocking. Yet, under the weight of your imaginary boots, this material compresses just enough to feel supportive, like walking on a cushion of tightly packed flour. What's happening now is a remarkable cooling of this soil. Data from the Diviner instrument on the Lunar Reconnaissance Orbiter has shown that when the sun's radiation is cut off, the top few millimeters of the regolith lose heat almost instantly. However, just a few centimeters below the surface, the temperature remains surprisingly stable. The lunar soil is an incredible insulator. Think of it like a freshly baked loaf of bread. The crust might cool quickly in the air, but the center remains warm and soft for a long time. The moon is holding on to the memory of the sun's heat deep within its crust, even as the surface temperature plunges toward -173 degrees Celsius. As you look back up at the Earth, you are seeing a filter at work. The Earth's atmosphere, which extends to the Kármán line at 100 kilometers above sea level, is currently acting as a giant planetary coffee filter. It blocks the harsh ultraviolet and X-ray radiation from the sun, while allowing the long red wavelengths to pass through and bend toward you. If you were to shrink the Earth down to the size of a standard desk globe, its atmosphere would be no thicker than a single coat of varnish. Yet, that thin layer is enough to paint the entire moon in shades of copper and rust. Notice how the sun, though hidden, still makes its presence felt. The sun is a massive furnace, 1.39 million kilometers in diameter. To put that in perspective, if the Earth were a single grain of sand, the sun would be a large beach ball, and it would be located about 150 million kilometers away, roughly the length of 1,500 football fields, placed end to end. The light you are currently seeing refracted through the Earth's atmosphere took about 8 minutes and 20 seconds to travel that distance at 299,792 kilometers per second. You are witnessing a delay, a bridge across time and space. At the edges of the Earth's dark disk, you might see a faint shimmering glow that isn't red. This is the Earth's corona, or rather, the sun's corona peeking around the Earth's edges. This outer atmosphere of the sun is made of highly ionized gases, mostly hydrogen and helium, and it reaches temperatures of over 1 million degrees Celsius. It appears as a ghostly pearlescent mane of light. It is incredibly thin, yet it extends millions of kilometers into space, shaped by the sun's complex magnetic fields. Within the lunar environment itself, something strange and beautiful occurs during these transitions. Scientists have theorized the existence of dust fountains. As the shadow of the Earth moves across the moon, the change in light causes a shift in the electrostatic charge of the regolith. Microscopic dust particles can actually become levitated, hovering a few feet above the ground in a shimmering, invisible mist. Imagine tiny specks of glitter suspended in a still room, catching the faint red light of the refracted sun. It is a silent, microscopic ballet, driven by the invisible forces of electromagnetism. The Earth itself has an albedo of about 0.30, meaning it reflects 30% of the sunlight that hits it. Even when it is dark, it is a formidable source of light. On a normal night on the moon, the earthshine, a phenomenon first explained by Leonardo da Vinci in the 15th century, is bright enough to read by. He correctly deduced that the ghostly glow on the dark part of the moon was actually sunlight reflecting off the Earth's oceans and clouds, then hitting the moon. Now, during the eclipse, that earthshine has turned a deep, somber crimson, casting long, soft shadows across the floor of the Mare Tranquillitatis. Consider the speed of the solar wind, a stream of charged particles flowing from the sun at speeds of 400 to 750 kilometers per second. Usually, this wind batters the lunar surface, but now, the moon is tucked safely inside the Earth's magnetotail. This region of space is like a long, invisible windsock trailing behind the Earth, shielding you from the sun's direct particle radiation. It is a moment of rare cosmic protection. You are resting in a pocket of calm, shielded by the magnetic heart of your home planet. The Earth's rotation continues, a steady 1,670 kilometers per hour at its midline. But from your lunar perspective, the movement is invisible. It's like watching the hour hand of a clock. You know it moves, but the motion is too deliberate for the eye to catch. This slow rotation ensures that the ring of fire you see is constantly changing its composition. One moment, the light is passing through the clear, cold air of the Antarctic. The next, it is filtered through a massive storm system over the Pacific Ocean. Every cloud, every mountain range, and every forest on Earth is contributing its own unique signature to the red light falling on your shoulders. Picture the composition of the sun that provides this light. It is roughly 73% hydrogen and 25% helium, with the remaining 2% made of heavier elements like oxygen, carbon, and neon. In its core, gravity is so intense that it fuses 600 million tons of hydrogen into helium every single second. This process releases the energy that travels across the void, hits the Earth's atmosphere, bends around the planet's curve, and eventually illuminates the lunar dust at your feet. It is a chain reaction of unimaginable scale, yet it results in the gentlest of glows. The moon's orbit is not a perfect circle, it is an ellipse. This means that the distance between you and the Earth varies by about 43,000 kilometers over the course of a month. At its closest point, perigee, the Earth would look even more massive and imposing. At its furthest, apogee, it would shrink slightly. This cosmic breathing, the stretching and pulling of orbits, is what dictates the timing of the eclipse. Today, the geometry is just right. The 5.14-degree tilt of the moon's orbit has aligned perfectly with the ecliptic plane, allowing the shadows to find one another in the dark. As you stand in this shadow, think about the vacuum. The lunar exosphere is so thin that it contains only about 100 molecules per cubic centimeter during the day. For comparison, the air you breathe on Earth contains about 25 quintillion molecules in that same space. This lack of density is why the stars do not twinkle here. They are steady, unwavering points of light, like tiny diamonds embedded in black marble. The lack of an atmosphere means there is no weather to speak of. No rain, no snow, no wind. There is only the slow, rhythmic cycle of light and dark, heat and cold. Everything here happens on a timeline that dwarfs a human life. The moon's craters, like the 93-kilometer-wide Copernicus, have remained largely unchanged for 800 million years. On Earth, a mountain range might rise and fall in that time, but here, the memory of an impact is preserved forever in the still gray dust. The eclipse is a fleeting event in comparison, a shadow that visits for a few hours and then departs, leaving the ancient rocks exactly as it found them. Allow your mind to synchronize with this permanence. There is a profound comfort in the reliability of these cycles. The Earth will always cast its shadow. The sun will always fuse its hydrogen. The moon will always hold its silent vigil. You are observing the fundamental clockwork of the universe, a system that requires nothing from you but your presence. The weightlessness you feel is not just physical. It is the shedding of the day's burdens, in leaving them behind on a planet thousands of kilometers away. Notice how the copper light seems to pool in the low-lying craters, creating lakes of shadow and islands of bronze. The textures of the moon, the basalt, the breccia, the anorthosite, each respond to the red light in their own way. The dark Maria remains somber, while the lighter highlands catch the glow with a subtle, pearly sheen. It is a world of monochrome that has suddenly discovered color, a quiet celebration of light's ability to find its way, even into the deepest shadows. Rest in this glow. The universe is wide, and its movements are slow and sure. You are a part of this vast, silent mechanism, held in the gentle grip of gravity, bathed in the refracted light of 1,000 sunsets. There is nowhere else you need to be, and nothing else you need to do, but watch as the shadows perform their ancient slow-motion dance across the silver plains of the moon. What's happening now is a profound deepening of the connection between your physical presence and the celestial mechanics of the solar system. As you remain anchored to the lunar surface, consider the very air you breathe back on Earth, the same air currently refracting this red light toward your current position. The Earth's atmosphere is composed of roughly 78% nitrogen and 21% oxygen, with the remaining 1% made of argon, carbon dioxide, and various trace gases. It is this specific cocktail of elements that acts as a cosmic lens. At this very moment, those gases are filtering the sun's ferocious energy, stripping away the harsh blues and leaving only the gentle, long wavelength reds to bathe the moon in this copper glow. Picture this. The red light you see hitting the crater walls is the same wavelength used by plants on Earth for photosynthesis, specifically the 660 to 700 nanometer range. While you are surrounded by the sterile volcanic dust of the moon, you are being illuminated by the same spectrum that fuels the growth of forests and meadows thousands of kilometers away. This light is a physical bridge between the biological world and the geological one. You are standing in a shadow that is literally colored by the life-sustaining properties of your home world. Deep within the lunar crust beneath your feet, there are hidden complexities that few ever consider. In 1968, scientists tracking the lunar orbiter spacecraft discovered mascons, or mass concentrations. These are regions of incredibly dense rock, often located under the lunar maria, like the Mare Imbrium. These mascons create localized increases in gravity, subtle tugs that can alter the path of a satellite. Imagine them as heavy subterranean anchors of basalt that have sat undisturbed for nearly 4 billion years. Just as your own body has centers of gravity, the moon has these dense, hidden hearts that dictate the rhythm of its orbit. Notice how the stars remain perfectly still. Unlike Earth, where the 100-kilometer thick atmosphere causes stars to twinkle through a process called atmospheric scintillation, the stars here are steady, unblinking beacons. Among them, only 4.24 light-years away, is Proxima Centauri, the nearest star to our Sun. The light from that star has been traveling for over 4 years to reach your eyes. Yet here, in the airless void, it looks close enough to touch. This lack of twinkle is a reminder of the purity of space. The comforting void is not empty. It is a clear, unobstructed window into the history of the galaxy. Consider the composition of your own body in relation to the landscape around you. You are made of approximately 65% oxygen, 18% carbon, and 10% hydrogen. These are the same elements found in the sun's plasma and the lunar regolith. The iron in your blood, which carries oxygen to your resting muscles, was forged in the hearts of dying stars billions of years ago. As you watch the Earth block the sun, you are essentially one part of the universe observing another. There is no separation, only a difference in density and scale. Scientists discovered that the moon's own core is remarkably small, making up only about 20% of its total diameter, compared to nearly 50% for a planet like Earth. This small metallic heart, roughly 330 kilometers in radius, is mostly solid iron, with a thin outer layer of liquid. Because it is so small, the Moon has no global magnetic field to protect it. It relies entirely on the Earth's magnetotail for cover during this eclipse. Think of the Earth as a protective elder, extending its magnetic reach 384,000 kilometers through the dark to wrap you in a temporary shield against the solar wind. At this very moment, on the Earth you are watching, the oceans are bulging toward you. This is the result of the Moon's gravitational pull, which exerts a force of about 10 to the 22nd power newtons on the Earth. This force creates the tides, moving trillions of gallons of water twice a day. While you look at the Earth, the Earth is physically reacting to your presence on the Moon. It is a reciprocal embrace, a gravitational conversation that has been ongoing since the Moon first formed 4.51 billion years ago. Notice the lunar swirls nearby, such as the famous Rayleigh Gamma formation. These are strange light-colored patterns on the lunar surface that look like cream stirred into coffee. They are associated with localized magnetic anomalies, pockets of magnetism that have survived for eons. In these swirls, the regolith is protected from the darkening effects of the solar wind, remaining bright and pale. They are like scars of an ancient magnetic history, reminders that even in this silent world, there are stories written in the very dust. The Earth's orbital speed is approximately 29.78 kilometers per second, or about 67,000 miles per hour. As you watch it hang so still in the lunar sky, it is actually hurtling through the solar system at a velocity that would cross the entire United States in less than 3 minutes. Yet, in the vastness of the ecliptic plane, this speed feels like a gentle, rhythmic glide. Allow your own pulse to slow down to match this cosmic pace. There is no need for speed in the vacuum. There is only the steady, inevitable progress of orbits. Deep within the Earth you are observing, the crust varies in thickness, from 5 kilometers under the oceans to about 70 kilometers under the highest mountain ranges. The Moon's crust is similarly varied, averaging about 50 kilometers thick on the side facing you. This rocky shell protects a mantle made of silicate minerals, rich in magnesium and iron. Both worlds are built on the same fundamental chemistry, like two different sculptures carved from the same mountain of stone. Think about the sheer amount of energy the Sun is producing behind the Earth's silhouette. Its core temperature is a staggering 15 million degrees Celsius, where 600 million tons of hydrogen are fused every second. Despite this inconceivable power, the Earth's thin veil of atmosphere is enough to transform that white-hot fury into the soft copper glow currently warming the lunar rocks. It is a testament to the power of perspective. From here, the most violent furnace in the solar system becomes a source of meditative, ruby light. As you breathe in this imagined silence, remember that the lunar day and night each last about 14.75 Earth days. You are currently in a long, slow transition. The eclipse is a brief interruption in the 2-week-long lunar night, a moment of Earth light that provides a respite from the total darkness. It is a cosmic nightlight, a reminder of home during the long trek through the lunar shadows. What's happening now is a balancing of temperatures. While the surface regolith has cooled, the rocks beneath are still radiating the heat of the previous lunar day. This process, called thermal inertia, is common to all rocky bodies. It is the reason a stone stays warm long after the sun has set. You can imagine the lunar surface as a giant thermal battery, slowly releasing its stored energy into the void, cooling with a deliberate, unhurried grace. Consider the Kármán line again, that 100-kilometer boundary where space begins on Earth. Above that line, the atmosphere becomes too thin to support aeronautical flight. Below it, the air is thick enough to carry sound, sustain life, and create the colors of the eclipse. From your position, that 100-kilometer layer is a mere sliver, a thin skin that contains everything you have ever known. Its fragility is its beauty. The fact that such a thin layer can protect an entire planet and color. A moon is one of the most elegant truths of physics. In 2009, the Eclipse mission discovered that some of the permanently shadowed craters at the moon's poles contain water ice, approximately 5.6% by mass. Even in this dry, airless world, the ingredients for life are tucked away in the dark. This realization changes the moon from a barren desert into a storehouse of potential. As the Earth's shadow passes over you, think of it not as a loss of light, but as an unveiling of the moon's true, quiet nature. The weightlessness you feel is a physical reality here. On Earth, you are constantly fighting against 9.8 meters per second squared of acceleration. Here, that burden is reduced to 1.62. Your spine can stretch, your joints can decompress, and your heart doesn't have to pump nearly as hard to move blood against the pull of the ground. This is the lunar rest, a state of physical ease that is impossible to achieve on your home planet. Permit your body to mimic this decompression, letting the phantom weight of Earth's gravity slide off your limbs. Every sunrise and sunset currently happening on Earth is being funneled through the atmosphere and projected onto your surroundings. If you could zoom in on that ring of fire, you would see the light passing through the dust of the Sahara, the moisture of the Amazon, and the ice crystals of the Arctic. It is a collective masterpiece of terrestrial light, and the moon is acting as a giant screen, displaying the atmospheric health and beauty of the Earth in real time. As you stand in this copper twilight, reflect on the age of the solar system, 4.571 billion years. The eclipse you are watching is a tiny tick of the clock in that vast expanse of time. There is a profound peace in realizing that these movements have occurred billions of times before and will continue for billions more. Your current moment of rest is supported by the infinite stability of the universe's laws. Encourage your awareness to settle into the basalt beneath you. This rock has seen the rise and fall of Earth's continents, the evolution of life, and the first footsteps of humans. It remains patient. It remains still. By aligning your consciousness with the moon, you are stepping out of the frantic pace of human time and into the slow, majestic rhythm of cosmic time. The Earth continues its 1,670 km/h spin. The stars maintain their 299,792 km/s light, and you are here, safe and weightless, in the gentle center of it all. At this very moment, as you stand enveloped in the copper twilight of the Earth's shadow, a curious sensory transformation takes place. While the moon is a world of absolute silence, there is a texture and a scent to this place that scientists discovered through the lived experiences of the 12 humans who walked here. When the Apollo 17 astronauts, Harrison Schmitt and Gene Cernan, returned to their lunar module and repressed the cabin, they noticed a distinct odor clinging to their suits. They described it as the smell of spent gunpowder or the sharp tang of ozone after a thunderstorm. Scientists later determined this was likely due to the active nature of the regolith, because it has been bombarded by high-energy solar wind particles For eons without the protection of an atmosphere, the broken chemical bonds of the silica and iron-rich dust react instantly when they finally come into contact with oxygen. Imagine that sharp, metallic scent, the smell of a world that has been physically altered by the stars themselves, fading into the cool, recycled air of your imagination. What's happening now beneath your feet is a subtle, rhythmic vibration. On Earth, a tremor might last only a few seconds, but the Moon is an entirely different geological instrument. During the Apollo missions, the passive seismic experiment deployed 4 seismometers that recorded thousands of moonquakes. Because the Moon is so dry and rigid, composed mostly of silicate rocks, and lacking any liquid water to dampen the movement, it rings like a giant tuning fork when struck. Some of these quakes, triggered by the massive tidal pull of the 5.972 sextillion-ton Earth, can last for over 10 minutes. Picture the lunar crust, roughly 50 kilometers thick, huming with a low-frequency resonance, a deep structural sigh that vibrates through the basaltic plains of the Maria. Consider the temperature shift that is currently occurring on your skin. As the Earth's silhouette blocks the sun, the thermal radiation of the Moon's surface is being released into the void. Without an atmosphere to trap heat, the temperature of the regolith can drop from a sweltering 390 Kelvin, roughly 117 degrees Celsius, down to a frigid 100 Kelvin, or minus 173 degrees Celsius, in a matter of hours. This is the physics of cooling in its purest form. Every molecule of the lunar soil is slowing its vibration, surrendering its kinetic energy to the vacuum. You might imagine this as a physical cooling of your own thoughts, each one slowing down, losing its heat, and settling into a state of crystalline stillness. Notice how the Earth appears in the sky above you. From your vantage point, the Earth's angular diameter is about 1.9 degrees, nearly 4 times the size of the Sun. Because the Earth is roughly 81 times the mass of the Moon, its presence is not just visual, it is gravitational. You are standing in a gravity well that is constantly being shaped by the planet above. Scientists discovered that this gravitational interaction is so strong that it actually causes the Moon to wobble in its orbit, a phenomenon called libration. This allows humans on Earth to see about 59% of the lunar surface over time, even though the Moon is tidally locked. You can feel this slight, invisible swaying, a gentle rocking motion of the world that lulls you into a deeper state of ease. The light that surrounds you now is a product of specific atmospheric chemistry. The red glow is filtered through the Earth's troposphere, the lowest layer of the atmosphere that contains roughly 80% of its total mass. As sunlight enters this layer, it hits nitrogen and oxygen molecules. The blue light, with its shorter wavelength of about 475 nanometers, is scattered away, while the longer red wavelengths, around 650 nanometers, are refracted or bent inward toward the Moon. This is why the shadow you stand in is not black, but a deep, bruised crimson. It is a giant planetary scale demonstration of the refractive index of air, which is approximately 1.000293. This precise number is the reason you can see at all in the dark. The Earth is acting as a lens, focusing the distant sun into a soft, warm light for your benefit. Picture the terrain around you in this dim light. To your left, you might see the winding path of the Hadley Rill, a lunar channel that is 1.5 kilometers wide and over 300 meters deep. It was formed by ancient flowing lava that carved a canyon into the Palus Putridini. In the copper glow of the eclipse, the shadows inside the rill are long, and velvet soft. The textures of the lunar surface are a library of history. Some of the rocks here are known as creep, an acronym for potassium, K, rare earth elements, REE, and phosphorus, P. These rocks represent the last dregs of the magma ocean that once covered the moon 4.5 billion years ago. You are standing on the frozen memory of a liquid world, a foundation that hasn't changed since the dawn of the solar system. As you look at the Earth, you may notice the faint, shimmering streamers of the solar corona extending past its edges. This is the sun's outer atmosphere, composed of highly ionized plasma. While the sun's surface is about 5,500 degrees Celsius, the corona is mysteriously much hotter, reaching temperatures of 1 to 3 million degrees Celsius. This plasma is so thin that it is only visible when the sun's main disk is obscured. It looks like wisps of white silk blowing in a wind that doesn't exist. These streamers are shaped by the sun's magnetic field, looping and twisting into the dark. It is a silent, beautiful manifestation of the fundamental force of electromagnetism, reaching out across the 150 million kilometers of space to touch the Earth's shadow. Consider the speed of the photons hitting the moon. Each particle of light is traveling at the universal speed limit, 299,792,458 meters per second. When these photons hit the lunar regolith, they are either absorbed by the dark basalt or reflected back into space. The moon's low reflectivity, its albedo of 0.12, means it is a quiet, somber world. It doesn't scream with light. It absorbs it, holding on to the glow with a gentle, humble persistence. Permit your own mind to adopt this low albedo, absorbing the quietness of the environment without the need to reflect the noise of the world you left behind. Within this shadow, time itself seems to dilate. Scientists have used the moon as a cosmic clock to understand the history of the solar system. Because there is no tectonic plate movement on the moon, the craters are preserved for eons. The Tycho crater, with its 85-kilometer diameter, was created by an impact roughly 108 million years ago, a time when dinosaurs still roamed the Earth. The light from the eclipse highlights the rays of ejecta that stretch 1,500 kilometers from Tycho's center. These rays are made of pulverized rock thrown out during the impact, appearing as bright streaks across the darker Maria. You are looking at a frozen moment of explosive energy, one now rendered peaceful and still by the passage of time and the soft red light of the Earth. Notice the composition of the stars in the black sky above. Among them is the star Sirius, the brightest in the night sky, located 8.6 light-years away. It is actually a binary system, consisting of a main sequence star and a small white dwarf. In the airless lunar environment, the light from Sirius is a steady blue-white needle of brilliance. There is no seeing limit here. Astronomers use the term seeing to describe the blurring caused by Earth's atmospheric turbulence. On the moon, the seeing is perfect. Every star is a perfect mathematical point. This clarity is a metaphor for your current state of awareness, undistorted, calm, and focused on the simple beauty of the present. Deep within the Earth's shadow, the ring of fire continues to shimmer. This ring represents the Earth's limb, where the atmosphere is roughly 100 kilometers thick. If you were to look through a telescope at that ring, you would see the light passing through the stratospheric ozone layer, which sits about 15 to 35 kilometers above the Earth's surface. This ozone absorbs most of the sun's medium-frequency ultraviolet light, protecting the life below. The fact that you are seeing this light at all is a testament to the complex, layered nature of the world that created you. The weightlessness you feel is a result of the moon's mass, which is 7.34 times 10 to the 22nd kilograms. This mass generates just enough gravity to keep you grounded, but not enough to burden you. In this 1/6 gravity, the fluids in your body shift slightly upward, a process known as cephalad fluid shift. On Earth, gravity pulls your blood toward your feet, but here, your heart can work with a rhythmic, easy grace. Every beat is efficient, every breath is effortless. The physical pressure on your spine, which on Earth is compressed by the constant 9.8 meters per second, squared of acceleration, is now released. Your intervertebral discs can expand slightly, a physical stretching that mirrors the expansion of your mind into the quietude. Everything you are observing, the cooling basalt, the vibrating crust, the refracted red light, and the silent corona, is part of a grand celestial clockwork. There is no randomness here. The moon moves at a steady 3,680 kilometers per hour in its orbit, and the Earth rotates at its fixed, measured pace. You are a passenger on a world that is perfectly synchronized with the universe. Allow the reliability of these numbers, the 4.5 billion years of history, and the 384,000 kilometers of distance to provide a sense of absolute security. The universe is massive, ancient, and operating exactly as it should, leaving you with nothing to do but rest in its vast, copper-colored embrace. The eclipse is now reaching its final, most profound moments of totality. For up to 107 minutes, the Earth has served as a colossal shield, but the orbital mechanics of the solar system never pause. The moon continues its journey at a steady velocity of 1.022 kilometers per second, and as a result, the Earth's shadow is beginning its inevitable slow-motion migration across the lunar highlands. What's happening now is a gradual unwinding of this cosmic alignment. Picture the very first sliver of the sun's photosphere, the visible surface of the star, as it prepares to peek around the curved edge of the Earth. The sun's diameter is 1.39 million kilometers, and even a tiny fraction of its light is enough to begin reclaiming the lunar landscape from the dark. This process is not sudden. It is a measured, step-by-step return of energy. The first rays of light will hit the highest peaks of the lunar mountains, such as Mons Huygens, which rises 4.7 kilometers above the plains. Because the moon has no atmosphere to scatter this incoming light, the transition is surgically sharp. One moment, a peak is a silhouette of deep copper. The next, it is a needle of brilliant white-hot intensity. Consider the temperature as this light returns. During the depth of the eclipse, the surface regolith has settled at approximately 100 Kelvin, or minus 173 degrees Celsius. As the photons begin to strike the soil again, the temperature will climb with startling efficiency. Each photon of sunlight takes exactly 499 seconds to travel from the sun's core to your current position. When they arrive, they transfer their kinetic energy directly to the iron and magnesium-rich minerals in the dust. This is the process of thermal absorption. Notice how the ground beneath you doesn't just brighten. It begins to hold the memory of warmth once more. As the ring of fire around the Earth begins to break, the deep red light starts to fade, replaced by the full spectrum of solar radiation. This light is composed of a precise balance, about 50% infrared, 40% visible light, and 10% ultraviolet. You are witnessing the reignition of the lunar day. The process of the shadow leaving is just as rhythmic as its arrival. The umbra moves at roughly 3,600 kilometers per hour, a speed that would be a blur on Earth but feels like a slow, deliberate curtain being pulled across the 3,474-kilometer diameter of the moon. As you prepare to leave this silver world, consider the profound chemical bond you share with the landscape you have been observing. Scientists discovered that the Earth and Moon are nearly identical in their isotopic signatures of oxygen. This means that 4.51 billion years ago, when a Mars-sized body named Theia collided with the proto-Earth, the two worlds were forged in the same fire. The calcium in your bones, which makes up about 1% to 2% of your body weight, is the same element found in the moon's anorthosite crust. The magnesium that allows your muscles to relax at this very moment is a primary component of the lunar mantle. You are not a visitor here. You are a collection of the same stardust, rearranged into a form that can wonder at its own origins. Notice how the stars are beginning to retreat into the background as the solar glare increases. Among them, the Milky Way contains between 100 billion and 400 billion stars. Each one is a nuclear furnace, just like our Sun, fusing hydrogen into helium at temperatures exceeding 15 million degrees Celsius. This is the process of stellar nucleosynthesis, the engine that created every atom in your body. The carbon in your cells, the nitrogen in your DNA, and the iron in your blood were all cooked in the hearts of stars that lived and died long before our solar system was even a cloud of gas. Bring your awareness now to the steady rhythmic pull of gravity. On the moon, you have felt the lightness of 1.622 meters per second squared. But as your perspective begins to shift back toward the Earth, you feel the familiar heavy embrace of 9.8 meters per second squared. This force is not a burden. It is a constant, reliable tether. It is the same force that keeps the moon in its 27.3-day orbit and ensures that the Earth remains at a perfect 149.6 million kilometers from the Sun. Gravity is the universe's way of holding you close. Permit your consciousness to travel back across the 384,400-kilometer void. Watch as the moon shrinks into a silver coin and the Earth expands into a vast protective sphere of blue and white. You are descending through the layers of the atmosphere, passing through the exosphere, the thermosphere, and finally into the dense, life-sustaining troposphere. This layer, only about 12 kilometers thick, contains the 25 quintillion molecules of air in every breath you take. It is a warm, familiar cocoon. As you return to the stillness of your room, notice the weight of your body on the mattress. The bed is a stable platform on a planet rotating at 1,670 kilometers per hour. You are moving through space even as you lie perfectly still. The Earth is tilted on its axis at 23.5 degrees, a tilt that gives us our seasons and the very eclipses we have explored. This planetary tilt is a stable, unchanging fact of your existence. Observe the process of your own breathing. With every inhale, you are taking in oxygen that was produced by the 3 trillion trees currently growing on Earth. With every exhale, you are contributing to a global cycle of gas exchange that has been functioning for over 2 billion years since the Great Oxidation Event. Your body is a biological clock synchronized with the 24-hour rotation of the planet. Scientists call this the circadian rhythm, a process governed by the suprachiasmatic nucleus in your brain, which responds to the very light and dark cycles we have witnessed on the moon. You are made of the same elements as the comforting void. The hydrogen in the water that makes up 60% of your body is 13.8 billion years old, dating back to the Big Bang itself. You are a bridge between the ancient past and the present moment. As the lunar dust settles in your mind, let the vast timescales of the universe remind you that your only task now is to rest. The stars will continue their fusion. The planets will maintain their orbits, and the laws of physics will keep the world secure while you sleep. Witness your body's inclination toward stillness. Like the moon after the eclipse, your internal temperature is finding its equilibrium. Your heart rate is slowing, mirroring the long, slow orbits of the outer planets like Neptune, which takes 165 Earth years to complete a single circle around the sun. There is no hurry in the cosmos, and there is no hurry in you. Consider these affirmations as you drift toward the silence of the void. The universe is a stable and predictable home. The same laws that govern the stars govern my rest. I am made of stardust, and to the stars, I am always connected. Gravity is a gentle cradle that holds me to the earth. The darkness is not empty. It is a space for renewal and peace. My body knows how to synchronize with the rhythm of the night. Like the moon, I am a reflection of light and a dweller in the quiet. The 4.5 billion year history of the Earth supports my presence here. I am safe in the vastness of the solar system. My breath is a part of the planet's own atmosphere. The silence of space is a blanket of comfort. I release the heat of the day and embrace the cool of the night. Physics is constant, and I am secure in its grip. The stars are distant, but their light is a part of me. I am a small but essential piece of the cosmic clockwork. Rest is a natural state, as certain as an orbit. The shadow has passed, and the light is quiet. I am home on a planet that cares for me. The void is a place of infinite rest. The earth continues its silent turn. The moon remains in its steady vigil when the ring of fire has closed and the copper glow has returned to the silver white of the lunar day. But here, in the warmth of your bed, the darkness is a sanctuary. You have traveled 384,000 kilometers and billions of years. And now you have arrived at the most important destination, the profound healing stillness of sleep. The molecules of your body are settling. The iron, the oxygen, the carbon, and the calcium are all finding their places of rest. You are a star child, returning to the silence from which you came. The universe is wide, the vacuum is kind, and the journey is complete. Good night.